Hello and welcome back to Mr. Kendrick's online math class. This is lesson 3.2, adding and subtracting linear expressions. Go ahead and turn to the next blank page in your math notebook and get this heading at the top. The learning target for this lesson is to find the sums and differences of linear expressions. And the success criteria is that you can explain the difference between linear and nonlinear expressions. You can find the opposites of terms that include variables, and you can apply properties of operations to add and subtract linear expressions. Go ahead and pause now. Make sure you get this written down at the top of your next blank page in your math notebook. Alright, here's a table, and we got a table of linear expressions and nonlinear expressions. Can you see the difference between a linear expression and a nonlinear expression? As we're looking at the table, in the linear expression column we have variables as well as constants, numbers without a variable. And in the nonlinear expressions we have variables, constants, as well as exponents. So the difference between a linear expression and a nonlinear expression is that a linear expression is an algebraic expression in which the exponent of the variable is 1. So all the exponents, all those x's in the linear expression column have an exponent of 1, and the nonlinear expressions have an exponent with a power of 2 or 3. So that's the difference. Also, important to recognize that in linear expressions there's this word linear or line. Okay, in linear expressions, when we graph them, we would get a graph that has a straight line. Might look like something like that, or like this. So those are examples of linear graphs, linear expressions graphs, and nonlinear expression would get us a curved graph that may look something like that, or maybe like this. Okay, so a linear expression would give us a graph with a straight line, and the variable has an exponent of 1. And nonlinear expressions, they have an exponent with a power of 2 or 3 or anything above 1. Alright, let's go ahead and look at some examples of adding linear expressions. Alright, so in this first example, we have x minus 2 plus 3x plus 8. Okay, now we've already practiced with combining like terms, and that's really what we're going to do here. So we have x, and the way that we can do this is we can do it just like when we were simplifying expressions the other day. We can just do it side by side, but we can also stack them up and add like a regular mathematical problem. Okay, so for this first one, I'm just going to stack them on top of each other and then do the addition. So starting from the right, negative 2 plus 8 would give us a positive 6, and positive x plus 3x would give us 4x. Okay, and now we have no more parentheses and no more like terms that we can combine, so these expressions are simplified. Also, something that I forgot to mention is that both of these are different expressions. So x minus 2 is one expression, and 3x plus 8 is a different expression, and then we added those expressions together. For b over here, I'm going to do it a little bit of a different way, and I'm going to do it similar to how we were simplifying expressions in our last lesson. And I'm going to rewrite this problem, and I'm going to put the like terms next to each other, so then it will make my addition a little bit easier. So for b, we have negative 4y plus 11y, and then we have plus 3 and minus 5. Okay, so now we've organized the two expressions with the like terms next to each other, and now we can add them up. So negative 4 plus 11, so negative 4 plus a positive 11 would give us a positive 7y, and positive 3 minus 5 would give us a minus 2. Now we have no more parentheses and no more like terms, so this one is simplified. Make sure you have both of these examples written down in your notes before you move on in the video. Alright, here's another example, and we're working to simplify. So we have two different expressions, and in example 1 there was no multiplication outside of the parentheses, so we didn't have to use the distributive property. But in this example, we do have a number outside of the parentheses, so we will need to use the distributive property. So I'm going to do that first, and then I'm going to reset my expressions. So we have 2 times negative 7x plus 3. So I'm going to distribute the 2 to this negative 7.5x as well as this positive 3. So 2 times negative 7.5x would give me a negative 15x, and 2 times positive 3 would give me plus 6, and then I'm going to bring down this other expression, so we would have plus 5x minus 2. Okay, so now I can look for like terms, and this time I'm going to do like we did in the last video, where I'm going to circle my like terms. So I have negative 15x plus 5x, and then I have plus 6 and minus 2. Remember that we always need to circle the operation to the left of the term. Alright, now I can combine. Negative 15x plus 5x would give me negative 10x, and plus 6 minus 2 would give me plus 4. Okay, so no more parentheses and no more like terms, so our expressions are simplified as negative 10x plus 4. Make sure you have this example written down in your math notes before you move on to the next slide. Alright, on this slide, there's 4 different problems for you to try on your own. Go ahead and give them a try. Pause the video now, and then come back and see how you did after you finish these 4 problems. Alright, I'm going to go ahead and use for number 1, I'm going to use the stacking method. So I'm going to have x plus 3 plus 2x minus 1. So positive x plus 2x would give me 3x, and positive 3 minus 1 would give me plus 2. Then we have no more parentheses and no more like terms, so that one is simplified. For number 2, I'm going to go ahead and use the stacking method again, so I would have negative 8z plus 4 plus 8z minus 7. Alright, so negative 8z plus 8z would give me, those would cancel out, so they would just be done. So those are canceled out. And then we have plus 4 minus 7, so that would give me a minus 3. We have no more like terms and no more parentheses, so that one is complete. Minus 3. Alright, number 3 we have 4n, or 4 minus n, plus 2 times negative 5n plus 3. So we need to distribute that 2 to the negative 5 and to the positive 3. So we have 2 times negative 5n would give me negative 10n, and then 2 times positive 3 would give me positive 6. And then I'm going to bring down these other terms, 4 minus n. And now I'm going to circle my like terms. We have positive 4 and plus 6. And then we have minus n minus 10n. So first I'll do positive 4 plus 6, which would give me a positive 10. And then I have minus n minus 10n. So those are both negative, so that would give a negative 11n. No more parentheses, no more like terms. So number 3 is simplified at 10 minus 11n. Alright, the last one here, number 4. We have 2 terms outside of the parentheses that we will need to distribute. So I'm going to start with 1/2, and I'm going to distribute to that w and to the negative 6. So 1/2 times w would give me 1/2 w, and 1/2 times negative 6, so we're looking what is 1/2 of negative 6, and that would be negative 3. And then we have 1/4 times w, and that would be plus 1/4 w. And then 1/4 plus 12, so we can do that multiplication. We got 1/4 times 12 over 1. And then we can cross cancel here. We divide by 4, we would be left with divide by 4, left with 1 here. And divide by 4, we're left with 3 here. So now we have 1 times 3, which is 3, over 1 times 1, which is 1. So our answer would be plus 3. Alright, so now we have distributed, so now we can combine like terms. We have 1/2 w and plus 1/4 w. And then we have minus 3 plus 3. And now we can combine. So 1/2 plus 1/4, we're going to have to get common denominators. So if we multiply this by 2, we would get 2/4 plus 1/4, which would be 3/4. And then we have minus 3 plus 3, those would cancel out. So we would just be left with 3/4 w.